Ladies and gentlemen, welcome to the Big Bear Math Channel. We couldn't be happier that you're with us here today to tackle this crazy topic. So we're getting into basic differentiation rules. It's just a fancy way of saying we're going to derive this function. We're going to find its instantaneous slope. Today we're going to focus on introducing you to the power rule. And I'll tell you what, if you've been grinding through the difference quotient and the long limit definition of a derivative, then this is going to go down in history as one of your very favorite math lessons. Guaranteed. Because we're going to make your life a lot easier. So as we get into the power rule to kind of set the stage, I want you to imagine for a second that you were trying to find the derivative of this function right here. And the only thing you knew how to use was this difference quotient that we have. And this is kind of the general formula that we've been using for difference quotient. Okay, so how would I apply that difference quotient to this function that was given to me? So first of all, they said, okay, we're going to replace each of these x's with the quantity x plus h, and that's what you're seeing right here. And then of course, you've got to subtract the original f of x function here. I've tried to use brackets, so I've got it all organized really nicely. The only thing that I did out of the gates here was I tried to square it. So that's what you'll see. This is the result of me squaring the x plus h. That's all I did there in that step. Okay, then the really fun part, I just did a lot of distributing. So I distributed this 5 through, distributed the 3, distributed this negative sign through a bunch of times. And so what you're seeing right here is the result of all of that distributing. And it's getting really crazy and chaotic at this point. But life's about to get easier. We got some terms. We started canceling some terms here. This 5x squared canceled with this negative 5x squared. 3x cancels with negative 3x, negative 4 with 4. And as that dust settles, I'm just left with this 10xh plus 5h squared plus 3h. What I did from there was I took out a GCF of h. So here is, let's see, here's my little GCF, which then canceled with this h on the bottom. And once you cancel those h's, that's your green light to go ahead and evaluate that limit. Up until this point, that limit as h approaches 0 has literally been just a decoration, and now it's going to have some meaning. We substitute the 0 for h, and we end up with 10x plus 3, and winner, chicken dinner. Here is our derivative function. But man, oh man, we do not want to have to do that much work every time. So ladies and gentlemen, let me introduce you to the power rule that's going to turn that 5-minute problem into about a 5-second problem. And I don't think anybody's going to argue with that. So here's basically what our power rule says, and it applies to any polynomial term basically. And we're saying, okay, if f of x, you've got a variable here. There's probably going to be some coefficient right here in front of that x, and that variable is being raised to a constant power. Maybe the exponent's a 2 or a 3 or a 1/2 or a negative 4. Okay, here's how we're going to derive it. We're going to take this exponent and we're going to multiply it by this coefficient right here. So that's where we're getting the n times the x. And then all you got to do is subtract a 1 from that original exponent so that the new exponent is n minus 1. Now, it's hard to really appreciate this rule just by looking at that type of definition. So we're going to work out 4 really nice examples here today. And the first one is we're going to basically redo the problem we just did, except we're going to do it a lot easier and a lot faster. Okay. And I'm going to apply that power rule. And basically, I'm going to go term by term. As I derive this, I'm going to treat this like 3 separate problems. Okay. And one thing I'm going to do just for emphasis is I'm going to rewrite f of x as 5x squared plus 3x to the first minus 4x to the 0. Okay. And applying the power rule says, all right, let's multiply this 2 by this 5 to make a coefficient of 10. Repeat the x. And now all you got to do is subtract a 1 from that exponent to make it a 1. Next I'm going to do is I'm going to multiply this exponent by this coefficient to make a 3. And then if I subtract a 1, I'm going to get x to the 0. Okay. And then the third term, I'm going to multiply this exponent by this coefficient to make 0. And then basically it doesn't even matter what comes next because 0 times anything is 0. And as I clean this up just a tick, we're going to get 10x plus 3 for my derivative, which is exactly the same answer I got a few minutes ago when we did the difference quotient. So yeah, life is getting easier. Let's see if we can make room here for this next one. All right, let's pick a different color. All right, we got a little green action. All right, so here we go. I don't think I really need to rewrite it, so I'm just going to jump in and start deriving. I'm going to multiply this exponent by this coefficient to make 40. Rewrite your x, subtract 1, so your new exponent's a 4. That's it. It's that easy. Multiply this exponent by this coefficient, so we're going to get negative 6. Rewrite your x, subtract 1, so now it's a squared. You're done. That's the derivative. And what's beautiful is, let's say you wanted the slope of f at x equals 1. Bam, just plug a 1 in and you've got your slope. It's that easy. All right, let's try. I got just a couple of little mini curveballs for you here. Let's see if we can spice it up, a little different color. All right. The key here is rewriting the f of x. Okay, we're going to use our strong algebra 2 skills to rewrite this as 3 times x to the negative 2. Once you get that x moved from the denominator to the numerator, you're ready to apply the power rule. But I think that's worth highlighting in your notebook is the power rule really doesn't apply until you get the variable in the numerator. So we're going to multiply the negative 2 times the 3, rewrite the x. Now watch this. If you subtract 1, be careful, you're going to get negative 3. And then I just like to rewrite my final answer so that I mirror the format of the original question. So there's my final answer. All right, one more to go. You're feeling like an expert already. Okay, again, just like the last one, the key to this problem is rewriting it. So I'm going to go 6x to the 1/2. And now I'm going to apply that power rule to get 3. So I'm multiplying the 1/2 and the 6 to get 3. Rewrite the x. Subtracting 1 is going to make negative 1/2. If I rewrite that bear, we're going to get 3 over radical x. And there is my final answer. So I hope that helped. And you are now a derivative expert.